statistician claims that the average salary of an employee in the city is no more than $55,000. So Gina, her colleague, believes this to be incorrect. So Gina thinks it's Curtis thinks that the salaries are $55,000 or less. Gina thinks it's more than $55,000 because she thinks something different. So they already stated the alternative hypothesis for us. We're supposed to figure out the p-value. Okay, to find out a p-value, you've got to know a test statistic. Okay, and so this is one mean with the population standard deviation unknown. So that means we use the t distribution. So here's the formula for t. So our sample mean is 56,500. Subtract that by the hypothesized mean of 55,000. Then divide it by the standard deviation of 3,750. Divide by the square root of 61. Okay, 56500. Subtract by 55000. Oh, I should have done the bottom first. Let's do 61 square root. Then do 3,750 divided by that square root. Then do 56,500 subtracted by. If you're not gonna if you're having trouble with what I'm doing here, just do it step by step. Subtract the top first. Write that out. Do the square root. Write the whole thing out again. Divide this by whatever you got the square root. Then write out whatever you have. Step by step. Make sure you get the same thing I get, about 3.124. Okay, because we need that test statistic. It's a right-tailed test. Meaning your rejection region's over here. We got a test statistic of 3.124. The p-value is the area, in the direction of the rejection region for your test statistic. Okay, because the p-value is the probability that you get as extreme a test statistic given that the null hypothesis is true. So we got 3.124, and we also want to note that our degrees of freedom is 60. Right, because the degrees of freedom with one sample mean is just 61 minus 1. So we can use a table to estimate that p-value. Okay, here's degrees of freedom of 60. Just check that sample size again. Yep. So 61 for sample size. That means 60 for degrees of freedom for one sample, for a mean. Let's see. 3.124 is even further back than this one. We still haven't hit 3.124. Still haven't hit 3.124. Still haven't hit it. You need to keep the table going to find out where 3.124 is. And what you're doing is, like, this is the approximate p-value for if you got 2.66 for a t-value. If you got t equals 2.39, this would be the p-value. So we didn't even get our p-value on the sheet. The p-value is less than 0.005. It's further off the table than where we can go. If you got like t equals 2.5, somewhere between this one and this one, then you'd say your p-value is between 0.005 and 0.01. Yeah, these two values here. Our p-value is even off the charts, so it's got to be even less than this number up here. That's the one that says what we just set up there. It's less than 0.005. Uh-oh, what did I do wrong? The probability of observing a value of t was... Oh, geez, I didn't read the wording very carefully. Or more, right? Because it's a right-tailed test. So that should have been this answer right here. So there's a lesson. Just don't try to do it too fast. The probability of observing a value or more. It's a right-tailed test.